Man, why is it so dark in this class? Hey, can you please turn on the light so I can do my work? Bro, that's hella far. Bro, it's like 10 steps away. Dude, come on. You don't even do all your work. All you do is play Clash all day. Dude, why are you so lazy? Just do it. Watch this.
Oh, I'll be back later. Let's have
How did you do that?
Please, allow me to explain. You see, the machine begins when the pair of scissors is used to cut the piece of tape holding the duct tape, which then falls and knocks over the basketball. This event demonstrates the gravitational potential energy of the duct tape converting into kinetic energy when it moves left to right straight into the basketball. It was deduced that the duct tape would be the best material to use here as opposed to a wooden block, because in order to have enough energy to move the basketball, either the height or mass of the object being dropped would have to be increased, as exemplified by the equation potential energy equals mass times gravity times height. The basketball then proceeds to roll down a wooden plank, which demonstrates kinetic energy as well. However, the speed of the object will be based on the slope of the plane as opposed to gravity. The speed of the object can be calculated by the equation speed equals distance times divided by time. To find the units for the distance, a ruler can be used to measure the length of the plank while we record how long it takes to roll down in order to find the units for time. The energy in this event can be found through the equation kinetic energy equals 1/2 mass times velocity squared. After the ball rolls all the way down and knocks over the book, which blows the balloon away and knocks over the dominoes, which then knocks over the book. It is important to note that the basketball is also accelerating as the basketball is influenced by gravity, which maintains an acceleration of 9.8 meters per second squared. But is accelerating at a slower rate as it is going down a slope as opposed to being in free fall. Thus, the acceleration of the object can be found from the equation acceleration, change in velocity, divided by change in time. All four of these events demonstrate the kinetic energy of each object transferring into the next object's kinetic energy every time it moves from left to right. Yet the energy increases as the mass of the next object getting knocked over gets larger, and as exemplified by the equation kinetic energy equals 1/2 mass times velocity squared. Not only does the energy increase, but so does the force of each object. This is due to each object retaining relatively same acceleration, but the mass of the next object increases as well, which leads to a greater force, which is exemplified by the equation force equals mass times acceleration. However, each event also demonstrates momentum and inelastic collisions, as it showed inertia in motion, and every time one object made contact with another, it ended up pushing it in the same direction as a slower speed. Finally, the book proceeds to knock over a football and cause the seesaw to tilt and finally turn on the light switch. This sequence depicts the kinetic energy being transferred from the book into gravitational potential energy of the football, and then back into kinetic energy of the plank moving upward, which finally leads to the light switch being turned on, thereby meeting your request. However, it didn't just magically work on the first try.
That's right. You know, I first got that idea from watching Remember the Titans and thought to myself, what if I could turn on a light switch with a football?
Alexis ran a few labs to get the best results. However, the most important lab he came up with sprung from the concern as to what if the potential energy of the football was too great, and he wrecked the seesaw. He then deduced that to decrease the potential energy of the football, he would have to decrease the height from which the football would be dropped. To solve this, he would create a lab to test the best height of the drop, and through a series of tests, he eventually settled on a height of 4 inches. As you can see, his data has been documented here.
Okay, 3 things. First, that guy's a nerd. Second, you're lazy as a rock. third, you do realize you could have avoided all of that had you just gotten up, walked on over, and turned on the damn flashlight. I didn't need to because I built this. What?